Alright, well, good morning, everybody. I don't know how this... Hey, Nico. I may need to change this to... Let me move this over. That's not what I wanted. I may need to change this to a dark background. Let's see. Because I think not that. Hope everyone is doing well today. Nico, I can't remember what time it is at where you are right now. Customize. Where is it to go dark mode on Chrome? I think I'm gonna wash myself out. Dark mode, dark mode, dark mode. More tools. Organize tabs, no. Let's see. There's a problem with my code, and I don't know what it is. Well, yeah, so everybody's been there with that. Well, best place that you want to start is if you're going to be looking at something, you want to try to find when was the last place it was working, is I guess the best way. No, not that. Why can't I find appearance for I just solved the problem. That's funny. Well, I'm glad. All right, everybody, I'm trying to find. It's the instructions are at the bottom right of a new tab page. Those are extensions. No, I do not want Google Hangouts. Because I want, if I can get this in dark mode, more tools, performance manager, developer tools, new window, no, find, edit, translate, organize, tabs. Because it washes me out. Okay. All right. Let me bring this over here. So what? Let's see. So here's the example that we finished up yesterday. And it was Roman numerals. So when I ran this yesterday, it was I got down here into this group, but if you really look at it, the gap is only 0.6 megabytes, and my speed is really, really bad. I thought I ran this one time, and I thought it was over here at like the 44 milliseconds. But all right. My sandbox engine is super laggy. All right, so I don't know what challenge we're going to do today. So when we when we pick a couple of them, let's see, we probably can do climbing stairs. Ooh, that sounds cool. Let's do that one. All right. Let's LeetCode climbing stairs number 30. No, I don't know where 30 came from. Number 70. There we go. Save. There we are. Okay. So let's see what the rules are. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. And how many distinct ways can you climb to the top? All right, let's make sure. Each time you can either climb 1 or 2 steps. And how many distinct ways? Okay, got it. So combinations of 1s and 2s. Interesting. All right, so this is going to be an interesting one. I love it. Okay. And I was just about to ask, can we do a 1, 3, of course, we go by 1s, and then combinations of 1s and 3s. All right, so cool. So if you're just jumping in, we've been doing this more and more, and I did a little bit of research, and because I wasn't sure if I could put anybody else's platform that's on the internet where I wouldn't get a copyright strike, but it seems to be okay because there are other, I guess I was unaware that other people just streamed completely LeetCode LeetCode and then would put the number in and the name. So we're going to do the same, and if I get a copyright strike, we will go from there. All right, so if you're just joining in today, glad to have you here. We try to do streams like this every day, and I'm trying to stay sharp for if I do get a technical interview, because I am currently unemployed. Let's see, I've got to figure out the dark mode because this is awful. I'm starting to wash out. My hair looks orangey yellow and splotchy. Does anybody on the stream know how to change Chrome to dark mode? Hang on, I gotta look. My stream is saying, YouTube's saying my stream is not that healthy. Let me see what the bit rate is. 4676. That seems fine to me. If you react to something and you're not using content of your own, then you're allowed. If it's not sound. Got it. Okay. That's good information. All right. So the first one we're going to do is climbing stairs. Is this in center or in screen? No. Hang on. There. And let me check the side. All right. That's good. Yeah, I was playing around with this yesterday. It was the platform is really cool. I think I've used it a couple of times. And I've helped some others with coding challenges, trying to solve them. All right. Feature dark mode, desktop, Android, computer, dark mode in Chrome. Trying to read where the dark mode is. At the bottom right of a new tab. The bottom right of a new tab. I don't know what. Using what? 100 megabytes? Sorry, I'm trying to find. Hey, Vinky, how are you doing? Glad you're here. Right now, before we solve, trying to see where I can get Chrome into dark mode, and I am having one heck of a time trying to find appearance underneath settings. Hang on. Settings, accessibility, appearance. There we go. Custom fonts, mode, device, dark. Okay, there we go. Hello, Abdul. How are you doing? Okay, so I changed Chrome to dark mode, but now LeetCode, everything here is white. Can I make LeetCode dark? We may have to just live with this, and I apologize. We can at least build this out and put this. We can do this over here, and we can come back and test it. So, all right. So basically, let's copy all this and bring this in here. There we go. All right. So Abdul, I don't know if how new you are here, if you've come and hung out before, but what we're doing is I've been live streaming for coming up on, I guess, 3 weeks now, with my new unemployment status. And what we're gonna do is I've been going back through old. Let me turn these back up. Now that we're back on. There we go. All right. And just doing coding challenges. And then I did a little bit of research, and everybody confirmed that if I am on the LeetCode platform, I'm not going to get a copyright strike, because I was not sure about anything, the copyright rules. So today, what the first one we're looking at is staircase. And what we saw was you can either go 1 or 2 steps. And I actually have another one somewhere that is how many steps to get to the top, and you have to navigate what step you're on. If you're on the bottom floor, you can't go negative, and so on and so forth. But all right, so you get in steps, and it's what are the combinations. So of course, I like this little example. Let's get Paint open. So if you haven't noticed, I love using Paint. I think Nico, what did Nico send? Is that that's a pretty good error message there, Nico. All right. The coloring's not that great. All right, so stair steps, and it says you can take 1 or 2. So basically, of course, what's this? 1, 2, 3, 4, 5. So if you have 5 stairs, of course, you're going to get the standard combination. If you go by 1, you're going to go by 1 or a 2. And if we looked in the example, the second example right there, take 1 step or 2 steps or 2 steps and 1 step, because the order in which you're going to do it. This is a legal mixed combination. Yes, at first this looks like it's different, but like I said, a picture's worth 1,000 words. So the first time through, you're going to take 1 step and then 2 step. Then the other time, this is completely different. So that's legal. So if you went up in steps of 3, you're going to have 1, 2, 3, 1 combination, 1 and a 2 and a 2 and a 1. So our answer is going to be, there's going to be 3 combinations, just like this. Does that make sense? So if you are new here, you're going to hear me say Python brain, human brain, programming brain, whatever term makes sense to you. You've got to understand the problem and even maybe the edge cases, because if the more you understand the outlier, the edge case, the better you're going to be able to solve these problems, because our brain does a lot of reasoning for us and fills in the blanks, and we are kind of unaware of that. Like you being an adult or just somebody who is very well aware of math, you understand what an even number is, but if you try to explain to a 5-year-old what an even number is, you have to get really granular and really specific. So let's go ahead and get started on this. And then we'll probably do this challenge and then something else, and then I need to wrap up because I need to head to I need to do something this morning. So let's see. So if you are brand new here, thanks for jumping on. I'd love to know what time it is where you are. Kind of gives me perspective of where we are. So let's see. We're going to have n. N is going to be, let's see if we can duplicate this one first. N of 2. Nope. My spider's been doing some weird stuff. So steps. So we have 2 variations. So we're gonna, I don't even know where to start with this, because I guess my brain is like, well, what? Not that. This. So let's kind of play around with this a little bit. Stairs. Because the better you understand, that's an awful step. The better you understand the problem, the easier you can explain it. The better you can explain it, the better you can solve it. So we're going up 3 steps. So here's our, going up here. So if we're given n, of course by 1, combination is 1. So by single steps, so single and multi, because I know we're going to get like some crazy thing like 101. Because I do have to compliment LeetCode is very, very good at edge cases. And edge cases test your program's rigor and your edge case comprehension. Never heard anybody else say that, but that's basically what it is. The better you understand, the more obscure the problem can be, because our human brain can handle pretty much anything, because we've been around a while and most of these problems, and that's why the whole concept of AI, because we really don't truly understand our brains. So when we're trying to show reason, because large language models, it's pretty easy to mimic writing, but mimic reasoning, yeah, I have some interesting theories, but they're all very, very rudimentary and very vague. So, all right, sorry about that. Sorry about that. But yeah, we've got to convert this over. So we have 3 steps. So singles, of course, is just n divided by 1. That's one combination. So let's see. One step. So would we put this into a list? So I'm thinking we're going to put this into a list of lists. So, all right. Combinations. So right now, single is equal to n divided by 1. All right, everybody like that? So single. Okay, so then I need to make this floor division, or all right, so in case, is there anybody who's brand new here that has never seen floor division? You can do this one of two ways, so I'll show you. Let's go back. So when you do division in Python, you get a float. Let's do print single. Sorry. Print single. Come up here. Boom, boom, boom. I get a float. Now there's two ways you can handle this. You can handle it here, and I get an int because I did floor division, or, and I like this here because then we can show code side by side, or I can wrap and do this. Now, here's an issue. I did a casting right here. Now, I didn't really understand casting until I started using SQL. Now, I did not change it. I just said display it differently. Now, if I do it here, I am changing it because I am doing it on this side of my equal sign. So now when I run this, it is a int, and we can check by type single int. Go back here. I know this is maybe rudimentary to some of you, but in case you are super brand new, I like to cover everything because, so I do this, I still get my int. Now I do single, print that out, and I do type on single. We're going to be completely thorough here. Boom, float. So you have one of two ways. So a good refresher of how things work. All right. Now, so I get single, but one. What I'd really need is all right. Now back to this. That is a lot of white. Let's start over. No, don't save. So this one is eluding me. So we may only do this one today because I am not visualizing the best way because I don't even know how I want to capture this. So if I have in, let's start small. 2. That is an awful 2. Thought I was getting better with writing with the mouse. All right. I have 2 steps. 1 step, 2 step. All right. One. Just throwing something against the wall. So I got my same error, forgot that I didn't change this back. Okay, I'll explain what I'm doing in just a second, see if I get it out of my head. All right, so let's go. This is the issue of getting things out of your head, Venki. What's Venki got? N minus 1 plus N minus 2. Interesting. What is that? Let's see what Venky's doing. What's the output for 5? That's where we're going. I wanted to start where I could prove something. So does everybody kind of see what I did here? So if we know, because I want to get a list of this, and then we can come through and add steps after and put a concatenation here and go do something along those lines. Well, we'd have a whole other problem with adding our plus. But right now, let's get... Oh, we just have to count them. That would be easy. So let's kind of go back to what I did here. So my singles is, I know it's one step. How many of it is it? So the combination of here is, how many one steps do you have for this? And it's 1. Sorry, I went to the extreme of, yeah, with Venky. Let's kind of draw this out. All right, so let's do 5. They don't need to do this big, Sam. There we go. 1, 2, 3, 4, 5. All right. So of course we have the standard 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then 1, 2, 3. Oops. Let's do this one at a time. 1, 2, 3. 1, 2, 3, 2. Now, this is where this gets fun. Then we have 1, 2, 2. Right? So if you think about it, all of these numbers add up to 5. Now we have to rearrange them. So basically, try it recursive approach. Not sure if, hang on, not sure if it's effective for large values. Yes, well, recursion. No, this is a combination problem. I don't believe this falls under, it's a variation of recursion, but right here, so let's see. So let's take into account, here's our main buckets of combinations of 5, right? But if we change this in any order and we mix up all the ones, they'd still all be 1. But I want you to think about this. This combination has, let's start over here. Let's get rid of, not resize. Let's crop this and get rid of this. So we're looking at this one. Whoa, not that. Looking at this. So it could be, so that, here's one of them. We have a 1, a 1, a 1, a 2. So let's start 2, 2, 1, 1, 1. 1, 2, 1, 1. 1, 1, 2, 1. You follow me? So the 2's come through in every combination of this. So this has 1. This has 4. So it's basically you have two options, and how many combinations are there? So then for this one, here we are, 1, 2, 2. Then 2, 1, 2, and 2, 2, 1. We have 3. So right now we have this one. So we have 1 plus 4 plus 3. So for 5 steps, we have 8 combinations of steps. Does that make sense? Does everybody follow me on that, of how we went about this? So this is the beginnings and basic designs of algorithmic design. And it's how my brain works. There may be a more efficient way with people with higher math skills, which that's a large population of the world. My math skills are, I wish I had higher quality math, because discrete maths are so interesting to me. I just can't do them. Upper level calculus, can't do it. I'm so intrigued by it. Just can't even begin to. I would love to be able to do discrete mathematics, but I just can't. All right, I am not smart enough. Let's go back to the stream to see if anybody have any questions so far about how in the world did I approach that. Let's go back here. So if it is 5, the answer is 8 combinations. I believe I've covered everything, because no matter what we do with the ones, they're still going to be a 1. And does anybody see, did I move? Because the 2 goes through everything. And of course, now there may be a math problem to this of the combinations. And that's kind of the point of noticing patterns in algorithmic design. I remember one of the first problems that I noticed was, and how cool math was I was helping my mom with something at work, and with margins and markup, and needing to find the formula to do the math to be able to do that. And now I'm exceptional with algebra. I'm very good with algebra. And I mostly go back to algebra whenever I'm approaching anything. Linear algebra, max-min problems, anything like that. So, all right. So if it's 5 stairs, there's 8 combinations. Let's see if there's some sort of pattern to this. And I love trying to do things. Ooh, that's bad. Let's get rid of that. And then this. All right, so now let's do 4 stairs and see if there's anything. So if you're just joining us, no, go forward. If you're just joining us, what we're doing through is we're going through a LeetCode challenge of going through stairs. 1, 2, 3, 4. All right. So, of course, our first combination is just a bunch of 1s. So then 1, 1, 2, and 2, and 2. Everybody agree? So can we rearrange this any? No. Can we rearrange this any? No. But we can rearrange this one. So I'm going to start with the 2 at the end, then 1, 2, 1, and 1. Oh, nope. 2, 1, 1. So right now, 4 stairs is 1, 2, 1, 1, not a 5, 3. Interesting. This is kind of how I approach things. What was 3? 3 had 3. Because I have a strong feeling. And then 2. Did 2 have 2? And 1 has 1. Let's do 6. Just kind of see where we are. Everybody seeing how I'm doing this? Let's move this down. Now we're going to look at 6. Brush 6. And see what happens here. 2 is 2. Who let me do that? 2 is 2. 3 is 3. 4 is 5. 5 is 8. Let's check. Vinky, have you already done 6? Because Vinky's usually 1 or 2 steps ahead of me. 1, 2, 3, 4, 5, 6. All right. Let's get rid of this. Jump. All right. So back to here. So of course we have our 1, 1, 1, 1, 1, 1. That's 4, 5, 6. Then an even number is going to be patterns of and all right, any other combination to get 6. 4, 5, 6. We got. All right, I think that's it. So now, technically, I don't need these anymore. So now let's come over here, see what we get. Of course, this is 1. This is 1. This is 1. Now let's see how many we get for here. So let's come over here. 1, 1, 2, 2. So I like to move them through the position and visualize how they are. Oops. 2, 1, 1, 2. All right, so we moved this 2 through. Does that make sense? I know this seems weird. I look at this as a dial. I remember when I was a kid, I had a bike combination and it had a spiral on it like a clock. So it rolled through. For 6, it's coming 13. Okay. Is there any sort of mathematical, does anybody see a mathematical combination yet? Because I have a strong feeling that there may be. So here we go. Dax. Yep, even on the weekends. So what we're doing is we are first examining a staircase problem, a LeetCode challenge problem of stair climbing, and it's number 70. So we're given a number of stairs to climb, and where our constraint is you can go by 1 or 2 steps and what combinations thereof. So right now we're just kind of building. I'm just going through and visualizing and just kind of walking everybody through how I go through and look at things. And let's see, let's get that in the background at least. Tone down some of all the whitey whiteness. All right. And just kind of looking at dials and how I see these problems that I solve. So this combination of course 6 steps. You take 1 step at a time. You do that one combination. Then 2 steps. Then 2 steps. 3 steps of 2. Then if you were going to utilize 2 steps of 2 and 2 steps of 1, what those combinations look like, and then 4 steps of 1 and 1. Alex, how are you? I wish I had more Spanish, man. I really do. Hope you're well. We're checking out a LeetCode challenge of, what do we call it? Climbing stairs. So this combination here, the combinations of 2 2s and 2 1s, is 1, 2, 3, 4, 5. Venky's already done the math, and Venky's saying it's 13. So I need to visualize it. I'm not doubting Venky. Venky's been on it and helped me notice all sorts of problems. So we're going to start here, and we're going to move through. And the way that I like to visualize this is I just move all my combinations through here. And I think about it as a dial. Because I remember one of my first things that I had to do was I had a problem. Is that right? 1, 2, 3, 4, 5. Did I not count the last one? Venky, I get 12. You get 13 for 6. Let's go back. Let me do, I feel like I messed up on this one. Let me go back and do it. All right. Because I feel confident that that's correct, but I do not feel comfortable about this one right here. So let me go back and recheck. Okay, we got 1, 1, 2, 2. All right. So 1, 2, 1, 2, then 2, 1, 1, 2, 2, 1, 2, 1, and 2, 2, 1, 1. All right, Venky, I feel pretty comfortable that I get 12. How confident are you that you get 13? Am I missing a combination? So our base combination is 6 1s, 2 3s, 2 1s, 2 2s, 4 1s, 1 2. Those all add up to 6. I can't think of any other combination of this. And then this is the order, which I am a little shocked that these combinations are the same. 5 for each. Because I did not, with this same number. So we have 1, 2, 3, 4, 5, 1. That's what's a little surprising to me, that this has 5 digits, this has 4 digits, and we still only have 5 combinations each. All right. That's 1, 2, 3, 4, 5. There, there, there. There, there, there. Okay. All right, let me do this one again. We'll double check everything. All right. So 1, 1, 1, 1, 2. I wonder if I left out, because that's 1, 2, 3, 4, 6. All right. Wonder if I left out a 1. I bet that's what I did. And Venky's being nice. No, here it is. 1, 2, 3, 4, and here it is. 5. All right, Venky. Double check me, because I get 12. So first what we're doing, we're looking to see if there's going to be a mathematical solution to this. And right now, I don't see one, but we could just do old famous brute force, and we'll get like an awful score of how long it takes. So don't be afraid of brute force just to get it to work. And then look for patterns in math to allow you to do something, because getting it to work is more important than, you can always improve cost and cost savings. Do you know how to use HTML? No. I've done some before, but no, I've actually know how to troubleshoot and things like that. No. websites have just never really intrigued me. I don't know why. I know that I could probably find a job very easily if I were to do that. But that's just not the way, like marketing and appearances and things like that. I just don't let the nerdiness of patterns and things like that, of having it tell us, like, I can tell a story about information, but visually telling a story, it just falls flat for me. Vinky, just double check, not sure, it's 13. Yeah, I only get simplistic media, and okay. Just double check, not sure if it's 13. Okay. I feel like it's 12, because let's go back. So yeah, 5, 10, 11, 12. All right. So then if we were to have 7, what in the world would 7 look like? Let's tighten that up a little bit. See if we can save some space. And there we go. Let's do 7, and then if we're not making any progress with this, that's awful. If we're not making any progress with this, then we'll start doing some brute force. But I don't like defaulting to brute force anymore. I used to, because that's all I knew. But now I try to be a little bit more elegant. You guys are probably hating me drawing steps. 3, 4, 5, 6, 7. All right. So it's basically the combinations of 6 with it, because I think there's going to be something here where we go 1, 2, 3, 5, 8, 12. We don't really need the stairs anymore, do we? Probably going, why is he still drawing stairs? He hasn't walked up the stairs in a while. All right, so 1, 2, 3, 4, 5, 6, 7. 1, 1, 1, 1, 1, 2. Okay. Then 1, 2. So 2, 2. We'll go backwards. 2 2s. 2, 4, 5, 6, 7. Right? 2, 4, 5, 6, 7. Okay. Then 3 2s. There we go. All right. So we can't adjust this any. So this is 1. Now we can do this a lot. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 2, 1. One, 2, 3, 4. 1, 2, 3, 4, 5. Okay. See how I have to visualize things, everybody. If you haven't noticed. 1, 2, 3, 4, 5, 2. Okay. 1, 2, 3, 4, 5, 6. So that's 6. And this whole approach may be completely wrong, but I've never done anything quite like this. So I'm kind of airing my dirty laundry, because what the whole point of this and the whole point of these exercises is for everybody who comes and joins here and is to just be comfortable. Do you want your own website? No, I've thought about getting my own website around, but it's just one more thing to maintain that I just don't have time for. I'm turning green. All right. Thank you. Nico. All right. There we go. Let's see. There we are. Get a little closer to the camera. That usually solves it. Get a little bit of. There we go. That should do that too. All right. So now here we are. 1, 2, 3, 5, and 7. And I'm going to move this one through. Now move the 2 through. One, 2, 3, 4, 5, 6, 7. Okay, interesting. That throws me a little off. Because see, you may be saying, why do I do this? Why am I doing it this way? Because I was kind of obsessed as a kid when, think about the number spaces. You have digits here. These can be 1 through 9, right? So think about these as a dial. Go 0, 0, 1. And as you turn the dial, you make them move through. So you go, okay, so this has 10 choices, 10 choices, 10 choices. So this is 10 to the power of 3. It's 1,000. So 10 times 10 times 10. So then when you have alphanumeric, you have 1 through 9, excuse me, I just made the biggest faux pas, 0 through 9. So that's how it's 10 times 10. Now when you add A through Z, that doesn't even look like an A through Z. Sorry, everyone. A through Z. So now you add these combinations. So now you go from 10 to 26. So you now have 36 alphanumeric, 36 to the power of 3. That's how you have all of these things. Nico, what'd you send me, Nico? Okay. Yeah, that's the trials and tribulations of learning to program. You're gonna be close, and then you're gonna be far away, then you're gonna be close again, and then you're gonna do something, and you're gonna be like, wow, that's really cool, and then you're gonna be like, how did I do that? It's just a journey. It's a marathon. It's not a sprint. That's life's tale. And I'm just probably at the beginning of just really figuring all of that out. Because some things I feel like I really know well. Some things I'm still figuring it out. All right. So here we are. 1, 2, 2, 2. That's 7. So we move this first one. So basically it's the 1 that's going to move through. One, 2, 3, 4. What is this? This is 18. All right. Any mathematical observations so far with this? If I turn down some of the lights, what happens? That's not bad. Oop, I got a flash of... Don't know why that should have done that. All right, I turned the lights down just a touch. What does it look like when I do that? That's not bad. All right, let's bring this back over here. So we are trying to find how many combinations Like I said, we can probably do this brute force. We're going to get the worst score ever. But again, it needs to work. But once we look at this enough and then we go have an aha moment, we're able to go through. So if it's odd and even, let's see. Let's go through. Let's see how we go about doing this. And I want to put this in my combinations because then I'm just going to go and count them. So, right, if you're just joining us now, what we did earlier was we took we did some floor division here. No, we didn't. We talked about the variation of you can do a floor division or an int conversion here. Now, we also, this is if it is an even number. So if there is a remainder, it's going to need to go to a single step. So let's think about that combination here. So this is going to be easy to come up with. So the way that I'm thinking about this, let me get rid of this. Is it the eraser? Whee! Alright. And I killed that one, so I'm going to redraw it. And 1. Alright. Can I make the eraser bigger? I don't know. That was kind of satisfying. Alright. I feel like I'm pretty yellow now. Let's do that. It's really overcasty here. It is trying to be fall here. It's trying to be fall here so bad. Alright. Okay, so we've got to devise a way. This one's going to be super simple. So what I did is the single steps is I just come through and I take my number of stairs, divide it by 1, multiply it by a list of 1, and I get my number of steps. Boom. Simple combination. Now, if it is an odd number, excuse me, that's an even number. That's an odd number for 1. No, it's going to work for 1 and an even and an odd number. And if it's a even number, dividing by 2 will be super simple, and then multiplying that by 2. And then we have that. So we need to devise up. So we have 2 problems here that we need to devise. If it's an even or an odd, and we get our base here, and we get these. And then we can probably rely on Python to give us the combinations. Hello, how are you? I don't believe I've seen you on any of our streams. It's nice to be here. Okay. Took the message away. I guess I'll call you It's. Glad to have you here, It's. Anuj. That's a guess. All right. So we're doing at a stair-step combination where we get a number of stairs that we need to climb. Then we need to find out how many. So just to give you we did longhand here. If we go up 1 step, there's 1 combination between 1 and 2 steps. If it's 2 steps, there's 2 combinations to go up. 3 steps, 3 combinations. Now here's where it gets a little bit, I don't think it's exponential. It may be. 4 steps is 5 combinations. 5 steps is 8 combinations. 6 steps is... Ooh, what am I... Is this Fibonacci? Is this a Fibonacci problem? Vinky, not a recursion problem, but a Fibonacci problem. Because I'm looking here. Doesn't it feel very Fibonacci? But like in sort of a reverse. Because I'm going here and then backwards and then I'm... Oh, this feels... I'm up 1. This seems really interesting as I'm going up. Well, I need to go that. Okay, just wanted to throw that out. It does have that feel. I just wanted to know. No worries. So I think how about we do the longhand here and get this solved. Let's get these created. And then we can let Python come up with combinations. So do you guys know iter tools and combinations? Have you seen any of my videos? I'm not gonna be hurt or too upset if anybody says no, but I have a very strong... I'll go the other way. I bet there's nobody in chat that has actually watched my iter tools playlist. Just curious. I won't take it personal. I won't cry. Alex, you have watched my iter tools playlist. How many are in my iter tools playlist? I'm gonna check right now. I wish there was a way for me to check and see who's watched it. That would be awesome. You have watched that. Okay. All right, Alex. So what is... Alex, are you on Discord? What is iter tools combination? What is it? Do you recall? Because I'm going to have to go back and look. And that's fine to use documentation. Kind of we touched on this earlier. Don't want to... Knowing what to use and remembering where to find it is more important than remembering exactly how it works. So for those of you who have not seen iter tools, I have basically... I wish it would tell me exactly how many playlists I have, but I have a lot of playlists and I have a lot of series. I have 94 playlists. Of course, I also have almost 1,100 videos. You're not on Discord. All right, because I was going to have you, because I thought it'd be easier to write all this out in Discord. But all right, combination. Let's bring in iter tools. All right, iter tools. So for those of you who do not know, iter tools is a very powerful library. Let's look. So as long as we can get this built, then we can go through and use combinations. It's going to be slow, but it'll work. It will work. All right, but let's look. Actually, let me do import iter tools as it. Dir on it. Yep. Help on it dot combinations. So right here, this is exactly basically what I did the longhand way. If I give 4 numbers, or range 4, which is 0, 1, 2, 3, and then I ask for all the combinations, and when I need 3 of them, we get this right here. Maybe it is with replacements. Or is it chain? Accumulate. Return a successive R-length combination of elements in the iterable. So let's use this. So we're gonna do x equals 1, 1. What are we doing? 7. So I need 5 1s and a 2. All right. Let's bring in iter, import iter tools as it. All right, now yes. New equals it dot combinations iterable x is r. R is the length of the combinations. So len x. Okay. So this may not be. Let's do. Oh man, the air's already on. I'm freezing. Combinations with. Help it dot combinations with replacements. Let's see if this ABC, give me a second. Python combinations of objects, all combinations of one list. Let me try something. I know there's one in iter tools because I've used it. All right. Let's look at help on the whole package. See if it goes back. This is the only thing I dislike about. All right. Hang on. Python iter Python iter tools. Come on. All right, let's read through this. Okay. Repeat, accumulate, batched. Oh, I do not know batched. This is on. Okay, so that's a new one in 3.12. Chain. Let's see. Anybody saying anything? If it's Fibonacci, then Schick should return 13, 7 for 21. Okay. All right. And that's not what we have, right? Because for 7 we have 18. All right. Just wanted to check. Drop while T. We may just have to 100% brute force this. Product combinations. Accumulate. Product. Because if no slicing, and no, it's not slicing. Compress. Combinations of a list. Compress, drop while, filter false. Take while, let's go back and just be thorough. We just need to be thorough. Combinations. Can we use combinations? 1, 2. Wait a second. Let's look at something. I'm overcomplicating this. Be very careful. Be very wary about over-engineering. So check this out. Would that be it? Combinations. 1s and 2s. Okay. Combinations range 2. Ooh, check this out. So as we iterate through the stairs, as we get, or would this be in? Depending on... Oh, we got to wrap. Okay, so then you also have to wrap this in list. Okay, apparently I'm not remembering how to use combinations. Okay, so combination range. From chain from iterable, ABC. It's combinations, right. So 1, 2, what did the document okay. Help dot it dot combinations. You're supposed to output. What'd I miss? Range 3, 0, 1, 2, and I'm asking for 3. Is it wanting the it's wanting the length? All right, so this isn't going to work. We're just going to have to go back. We're going to have to brute force this. That I know there's something here. There's a here. There's a here. So we're just gonna have to brute force this, and this is again, LeetCode is fantastic at edge cases. So where the tools at hands will not work, I'm extremely impressed with all of that. Let's get up here and not be yellow. All right. So we need to get here, and then we need to move through. So how would we move this through? That's going to be good. And this is technically an easy question. I love it. All right. But we can do this. So if it's an even number, the ones are always going to be easy. So let's design our algorithm. If it's even, and then the combinations of 2s. Then where my brain is going is every time there's a 2. So we can look at it down here. So how about we look at 6? So we have, it should be 6. So our combinations, here's our smallest list, and here's our longest list. And then I can break each 2 into 1s. So here are my four base cases, and then can't rearrange these, but then I can rearrange these two. Does that make sense? Does everybody see what I did right there? So let's see if we can build this. So this is for even, and I know this is as brute forcey as it gets, but we thought this was some sort of Fibonacci, but it's not. There probably is some very cool. If somebody's better at math in here than I, please have at this and see if you can see the combination. Maybe if we just look at them as 2s, if we look at the evens and we look at the odds, now that would be interesting. Oh, because I don't want to give up on that. So if we go even, oh, I want to keep doing this. Sorry guys. I can't give up on this yet. I don't want to give up on this yet. Hang on. So when I go from here to here, it's 2. This is odd. This is even. All right. 2. Then that was 5. And then 10. Then as they go up here, it was 3. And then 7. Doesn't that look even more Fibonacci? So as I was moving up, so I broke it up, not just from the previous one, but from the previous even or the previous odd. I think I just pointed the wrong ones. Previous odd or previous even. And then I ascended. Because the combinations change as you're moving. All right, let's look at, let me see if I can do this. I'm going to try something. Can I shrink this too? Everybody see what I'm seeing? But I also know I'm crazy too, so that's fine. No way I can shrink it. Okay, so now let's do 8. Let's do 8 and 9, and then we'll go to the brute force. All right, if that works for everybody. 8, 9. All right. So 8 is super simple. It's 2, 2, 2, 2. 1, 1, 1, 1, 1, 1, 1. Is that 8 yet? No. 4, 4. All right. So now let's break this up. We're going to start back. That's not good. 2, 2, 2, 2, 1, 1. 2, 2, 1, 1, 1, 1. 2, 1, 1, 1, 1, 1, 1. Then 1 up, and then we're back to here. Let's move this up here. Well, that went faster. I don't need that big. And boom. That even feels like a pattern. Wait a second. Yeah. Anybody else see it? 2 steps, between 1 and 2 steps, and then this breaks up. So 3 and 4 steps. This is step 3. This is step 4. I might be crazy, but hang in there with me. Then this is 1, 2, 3, 2, 2, 1, 2, 1, 2, 3. Oh, I thought I had something. So there's something. I'm close. I'm very, very close here, because as we go through this, on step 1 there's only 1. Then we go up to 2. It's 2 stairs, 2 steps, or 1 step. 2. Then we go up 3 steps, 2 step, 1 step, because you can't when I go to my next odd, it's going to have one more step, and it could be either or a 1 or a 2. Okay. There's something. We're close, or I feel like I'm close, but we'll need to see. So, all right. This is, of course, no. This is no. Okay, here. This is a course 1. This is a course 1. This is 2, 2, 2, 2. Oh, let's move that one through. 1, 2, 1. Then 2, 1, 2, 1, 1. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. All right. Now let's move the second one. 1, 1, 1. Nope. Sorry. All right, so now this one is the farthest over. All right, gee whiz, 1, 2, 3, 4, 5, 6, 7. Woo! Okay. Let's get rid of this. And again, I could be over-engineering this completely, and somebody goes, no, it's just blankety blank blank blank. All right. Highly possible. But this is just where my brain starts, and I have to be, it's always very inefficient. All right, so we're going to move with this first one. Nope, I'm already wrong. Okay, let's go back. That was inconsistent. So we're going to move this 2 through, since there's more of those. 2, 1, 2, 1, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 2, 1, 1, 1, 1, 2. All right. Whew. We're getting kind of crazy here. So then 1, 2, 1, 1, 1. I think I've already lost track. There we go, because I got 4 ones. This is a ton. Thank goodness this is the last one. We were running out of space anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, this is interesting to me. Okay. Let's get rid of this. Got a little crazy here. Alright, our last one. 2, 1, 1, 1, 1, 1. That's 5, right? So what I guess I'm tiptoeing around the combinations of 2s and 1s. So as we go up a stair, as we go from a even, so an even to an odd, I have one more step. And that first time through, it has to be, there's only just one more combination. Then as I go through, then I add another step. I get how many more combinations. And then it becomes, so so I feel like there's something there in my head, but I can't quite articulate it. So let's move the 2 through here. This is supposed to be 5 of them, right? Yep. There we go. 1, 2, 3, 4, 5, 6. 10, then 13, 14, 24. All right, so we have gone, how long have we been on? We've already been on an hour and a half. So thanks for hanging in there with me. Hope you guys are coding or trying to problem solve this along with me and are making some sort of advances. Now, check this out. So from here to here, it's 12. The difference. So if we go even to even, that feels very patterny. Feels very, very patterny. And I know I'm just I feel that it just feels like there is something there, but the pattern would have to be based on, I would have to know what the last one was. So, all right. Let's go into let's just brute force this thing. But with how many steps was this? This was 8. This was 8 steps, and we had 1, 2, 3, 4, 5 main combinations. Oh. I think I just knocked over my screen. There we are. I need to come up with a better setup. Hang on. Sometimes when I have the chair leg the way I have it, it does not want to cooperate, and I have it leaning. I have this rigged up pretty unconventionally. Okay. Well, I really thought we'd at least solve one of these before the end of the day. Oh, crap. It's 9. 'Cause I got to leave here at 9:30. And I got to get ready too. So, well, this was not that. You're going to go, Nico? All right, cool. I think we're going to wrap up too. I may spend some time on this today, but I have to go. The oven did not go well. It is fried. I had to get an electrician over, and they said I was wiring it correctly. It is the oven, so we will go from there. So that is that. Sorry for the not so productive, but I will spend some time on this, and I'm close. I know that there's some sort of pattern here, and that's one thing that I am pretty good at. So I think when we get to this and we then cycle the combinations around, we'll be able to find something. So yeah, I think I'm going to wrap for this morning because I do need to do some things before I go. But please, if you've not joined the Discord, please do that now. If you have any questions that are, you want to share code, ask about code, that is the best place to send it. Because you're able to share. You can hit me in a comment. I do respond, but if it wants to be a back and forth, it is best to do it in Discord. It is a lot easier. You can also get some comments from other individuals because people have Discord on their phone and have the app. So just want to share that. So thank you everybody for joining us today. Sorry that this was a little anticlimactic, that I was not able to solve this one. I thought it was going to be a pretty easy one, but there's a something here, and I just haven't quite noticed the pattern yet. But thank you everybody for joining us today. If you've not hit the like button, please do that, and if you have not subscribed, please do that as well. Please make sure, don't know which one we're going to do tomorrow. If I can figure this one out. I still have the parentheses one that I've got going on, but I got an oven that I got to replace, so don't know exactly when we're going to do that. Need to go shopping for that. Need to dispose of the old oven. But thank you, everybody. Thanks for coming and hanging out this morning with me. Hope everybody has a great day, and we'll just talk next time, okay? Thank you, everybody.